Let's see this question. Construct the minimal DFA that accepts all strings over the alphabet A, B, where each string contains exactly 2 B's. So the number of B's in each string is exactly equal to 2. Let's see what are all the strings in the language. The minimal string BB, ABB, BBA, BAB, AABB, ABBA, ABAB, BAAB, BBAA, and so on. In each string there should be exactly 2 B's. So the finite automata for the minimal string would be Q0. On seeing B, we go to Q1. On seeing B from Q1, we go to Q2, and we accept this because we need to accept the minimal string. At each state, I can see any number of A's. No matter how many A's, I will be in that state itself, because we are not counting the number of A's. We just have the count over number of B's. So at Q2 also, on seeing A, I will be in Q2 itself. We can see that Q0 is complete, Q1 is complete, and Q2 is not complete. So what if we have a B at Q2? If we have B at Q2, we will have at least 3 B's. So how did we reach Q2? On seeing 2 B's, right? On seeing 2 B's at any position. So when we see a B here at Q2, I will be seeing one more B which violates the condition over B's. So I will be going to a dead state to reject such strings. On seeing one more B at Q2, I will be going to the dead state. At dead state, no matter how many A's and B's I see, I will be in dead state itself. So this is the DFA and this is the minimal DFA. We cannot reduce the number of states from 4. In the similar lines, we may be asked to construct DFA for each string containing at least 2 B's. That is, number of B's in each string is greater than or equal to 2, or we may also be asked to construct DFA for strings containing at most 2 B's. That is, W number of B's in each string is less than or equal to 2. We will see these two variants now. So if we have B number of B's in each string is less than 2, if this is the condition, the language would be epsilon, because epsilon has 0 B's, A has 0 B's, AA, this string AA has 0 B's, for that matter any number of A's, it can be A star. A star is 0 or many. A star is 0 or many A's. What if we have single B's? So single B is also in our language. B is one of our minimal strings. AB, BA, AAB, ABA, and so on. In this, each string will have exactly 1 B. What if we have 2 B's? Like BB, ABB, BAB, BBA, and so on. In this, each string has exactly 2 B's. If we have 3 B's, we need to reject all those strings like BBB, ABB, AB, BAAB, and so on. These are all the set of strings in this language. These are the strings which are to be rejected from the language. So the DFA would look like, since epsilon is in our language, the initial state would be final state. On seeing a B, we go to another state and accept it because B is in our language. On seeing one more B, we go to final state, some final state, because BB is in our language. If we see one more B, at this state we reject this string because we have three B's in this string which violates our condition. On each state, no matter how many A's I see, I will be in that state itself because I don't have any condition over A. So these are the transitions over A at each state. At dead state, if we see an A or B, no matter what we see, we will be in dead state itself because we already have reached the dead state and there is no point in going back to any final state. This is the minimal DFA for strings having the number of B's in each string is less than or equal to 2. This is at most 2. What if we have at least 2? Like the number of B's in each string is greater than or equal to 2. So here the DFA would be, so the minimal string in this language would be BB, and we can have any number of B's greater than or equal to 2. So all these strings will be in our language. So considering the minimal string, we try to construct the skeleton DFA. So on seeing B from Q0, we go to Q1. On seeing B from Q1, we go to Q2 and accept this because BB is in our language. No matter how many A's I see at Q0, we will be in Q0 itself because we are not counting the number of A's in each string. Same condition applies over Q1 also. Same condition applies over Q2 also. So I can see that Q1 is complete, Q0 is complete, Q1 is complete, and at Q2 there is a transition missing over B. So if I see any B at Q2, we should accept it because we have already seen two B's which satisfies our condition. So no matter how many B's I see at Q2, I will be accepting this string. So this is our minimal DFA for strings having number of B's at least 2.